Okay, so this lesson is going to be pulled from a few different sections in our book, but we're going to be talking about graphs of linear functions, and all of what we're doing today is without a calculator. I do think that almost everything that you're going to see today you've seen before, so really this is just a chance. It's going to go probably pretty quickly, but it's a chance for me to just refresh your memory and make sure that you really understand or remember things correctly. So first of all, let's talk about that word linear. Linear, we've talked about this already in class. You've seen it on the wall. Linear means straight line. So all of these functions are going to be straight. And there's a few different kinds of linear graphs. So there are, I'm just going to kind of draw 4 options for us here. And I've said that these are all functions. Remember, we made a note in class the other day. We talked about how this one is actually not a function because it doesn't pass the vertical line test, right? If we put our pencil on it, it's going to touch an infinite amount of times. These other functions, though, these other functions, and all of these are actually examples of linear things. So our first one is an example of an increasing linear graph. And when we talk about, and we're talking about like the behavior as it goes to the right. So even though it has 2 arrows on it, like one that's going down, people look at this and say, well, this side is decreasing. Well, you always read left to right, right? So I'm talking about this arrow on the right-hand side. What is it doing? So this is an example of increasing. Another way to think about that is I'm writing, like my writing goes up, right? If you wrote your name on the top of this, that would go up. So that's an example of increasing, which is going to make this other line an example of decreasing, right? If we're looking at the right-hand side. And then we have these other 2 lines, and we've got this one that is up and down, we said is not a function, and it is a vertical line, if you remember those words. And the other one is horizontal. And that's because we have to use other names for those because those aren't increasing or decreasing. We could also make a note that this horizontal line has a constant. It's just a constant line. You've kind of talked about that when we talked about functions and introduced the graphs to begin with. So some words that go with this are words about slope, which you've learned before. So when we talk about slope, we label these lines in a different way. We say like the slope of this first line is a positive slope because it's going up. The slope of the second line is a negative slope. Now, the 2 that you might get confused or might not remember correctly are the vertical and horizontal. So vertical slope, this is actually going to be called undefined. And it has to do, you can kind of think about that because it's not a function, it can't have a slope. And then our last slope here is going to be a slope of 0, which you can either write the number 0 or the word 0 either way. Now, slope, if you remember from from pre-algebra, from 8th grade, or if you've had algebra before, slope is going to be how we count the change of how a linear function is moving. Linear graph is changing over time or whatever is being measured. And there are a few different formulas for slope. So the ones for when we're talking graphically, when we want to measure the slope, we want to use the formula rise over run. And that just tells us, we usually think about slope as a fraction, so that's going to tell us how far up and then how far either to the left or to the right is going to create this slope for us. And like I said, there are going to be a few other formulas that we learn, but for right now, rise over run is the only formula that I need for you to know. All right, so the easiest form to graph in is what we call slope-intercept. And you've learned this before. It's y equals mx plus b. So it's in this format where y equals something. And the m, a lot of times mathematicians use smart numbers or smart letters for when they're describing formulas. I don't think this one was very smart because m and b don't really stand for much of anything. The b itself gives us the y-intercept, and the m tells us the slope. So think about that, like slope and rate should kind of go together in your mind because remember rate was what we put with the x variable. And so that is how something is changing, which is the slope. And the y-intercept was always like the number by itself was always the starting point. So one thing that you can remember is that the y-intercept is the start, or the b can stand for begin, if you want to think about it that way. And then the slope is going to tell you the rate or how to move, if you want to think about the m standing for move. So let's look at what this looks like in progress. So I've got 3 examples for us. So if we look at example A, my y-intercept is -6. That's where I'm going to begin. So I'm going to plot -6, and we said y-intercept, so that's going to go on the y-axis. And then I'm going to plot a slope of 5. And I told you last that slope is rise over run, and that I want slope to be a fraction. So I can make any number a fraction by putting it over 1 if it isn't already. And this is going to tell me to rise 5 and to run 1. So I'm going to do that from my beginning point. So I'm going to start down here at this beginning point, and I'm going to rise 5. 1, 2, 3, 4, 5. Notice I'm counting jumps, not like points. And then run 1. So that's going to make my next point right here. Rise 5, run 1. I'll do the same thing. And the best thing to do is to complete this pattern as many times as you can on a given graph. Rise 5, run 1. Now, if you had, well, I'll leave it there. All right, that's rise 5, run 1. And I know that this is correct. I want to connect it. I know that that's correct because my slope there is positive, looks positive, just like the equation said that it should be. All right, so now if I go ahead and look here at example B, this one is similar format. It tells me to start at +1. The difference here, 2 differences. One, the slope is already a fraction, which is nice. But one thing that sometimes tricks people is, where is this negative going? Like sometimes people aren't sure if that negative is like a -2 over -3, or if it's just a -2 or just a -3. So I need you to know that this negative sign can only apply to one number at once. So it is either, let's see, we can think about this as either being -2 over 3 or 2 over -3. But it can't be both, all right? We'll talk about why that is tomorrow. So that means I'm going to rise -2 and run +3. Well, to rise -2, that means to go down 2, and to run +3, so that's running to the right. So -2 over 3 again means to go down 2, to the right 3. I can continue that pattern. And one thing we also want to do is talk about how to get points in the other direction, because lines have arrows on the end, so they go on forever. So I can also go up 2 or to the left 3. That's what this 2 over -3 means, is to go up 2 and to the left 3. And I can do that again, up 2 until the left 3. And notice that when I do that, it just continues that same linear graph in the opposite direction, so that I have a more complete picture of what it looks like. All right, and we're going to do one more example like this. That's example C here. Now notice example C does not tell me where to begin. There's no starting point here. So I'm going to start in just the basic place, which is at 0. If it helps you to write +0, you can do that. And then -7, I can make that a fraction, make it -7 over 1. So I'm going to count my slope again. That's down 7, 4, 5, 6, 7, and to the right 1. Or if I want to go the other direction, I'm going to go up 7 and to the left 1. That's going to keep my graph going in both directions. All right, so the last thing I want to show you is how to graph those horizontal and vertical lines that we talked about, the ones that have 0 slope and are undefined. So our first line here is y equals 2. And I like to notice that there is no x in this equation. This is not like y equals 2x. It's just y equals 2. So there's just a y value and there is no x. In my mind, I think there's no x, so this can't touch the x-axis. So then when I think about that when I'm graphing, y is going to equal 2, so I'm going to hit the y-axis at 2, but I need a line that only hits the y-axis at 2 and never touches the x-axis. So if you think about that for a second, that should end up in this line right here, which is a horizontal line with 0 slope. So y equals is going to give me horizontal lines with 0 slope. All right, my x equals lines, if I use that kind of same mentality, my x equals line has no y in the equation, so that means it can't touch the y-axis. So then I need to hit the x-axis at -3, all right, that's right here, and it can't touch the y-axis at all, which means this line is going to end up running straight up and down or completely vertical. And that's going to be an example of that undefined slope. All right, so make sure you have in your notes also how to graph these horizontal and vertical lines.